because the Earth started to warm up. In fact, when people talk about warming of the Earth, it's been occurring for 300 years. The temperature bottomed out around 1700 and has been unevenly rising ever since then. Now, eventually thermometers came along. So the measurement of temperature with thermometers roughly starts around 1850. And this is the trend. It's increased, the average temperature of the Earth, according to our thermometers, has increased about 1.1 degree Fahrenheit in the last 160 years. But there are warming and cooling periods lasting 25 to 30 years. Warming, cooling, and warming. One of those warming periods was from 1978 to 1998. That ended in 1998, and what you may have never heard before is that there has been no warming of the Earth since 1998. This is not circulated in the media. They either don't know it or don't want to say it. They probably just don't know it. The global warming advocates say that the last decade has seen record high temperatures. But that's only in a very brief period of time in the modern era of thermometers. Back in the medieval warm period, it was as warm or warmer than today, and back in part of the Roman Empire. In the Roman warm period, it was as warm or warmer than today. And again, the temperature has been rising since the Little Ice Age. The temperature measurement has only been a very brief period of time in history. Now, this is the last 3,000 years of temperature, and look what it's doing. It's been falling for 3,000 years unevenly. If the trend continues, say we've peaked, as we did here, we may be looking at a period of rapid global cooling in the future. History tells us the interglacial will end. We've already been through 10,000 years of it. They don't last forever. So someday, that's going to be the big challenge of humanity, is when it gets cold again. So the Earth is not record warm. The Earth is not warming rapidly. The recent warming ended more than a decade ago, and the Earth was 1 to 4 degrees warmer 3,000 to 9,000 years ago. But we are told there is a climate emergency. Storms will become more violent in the future, we hear. More tornadoes. More heat waves and droughts in the future. More devastating floods. Bigger hurricanes. More blizzards and record snowfall now because of global warming. All of this makes no sense. Less temperature difference between the poles and the equator equals less potential energy to make storms. In a warmer world, you have less temperature gradient between the poles and the equator. Less potential energy to make storms. Storms would be weaker in a warmer world, not stronger. But you have to be a meteorologist to know that, or to understand that, at least initially. We're told the glaciers are going to melt and that there's going to be massive sea level rise, flooding cities within 100 years. And that many animals will go extinct. 25 years ago, it was a summer heat wave. Today, it's global warming. All of this because of global warming predictions. The UN Intergovernmental Panel on Climate Change was formed in the mid-1980s to discover the human impact on climate. And they have a big meeting every year, I should say, well, they do every year, but then a big one every 5 years. And they issue predictions about what's going to happen. The IPCC, the Intergovernmental Panel on Climate Change, average temperature rise by 2100 is supposed to be 7 degrees Fahrenheit. That's the mid-range. But what about all the other forces that have always affected climate? Like clouds. There are many different kinds of clouds. They have different effects on temperature. The oceans. The oceans contain 1,000 times more heat than the atmosphere. Big impact on climate and weather. And of course, the sun. Well, here's the Earth's energy balance. The radiation coming in from the sun is balanced by the radiation going from the Earth's surface back to space. The sun warms the ground warms the air. So heat coming in is equal to the heat going out. That generally keeps the temperature pretty steady. What we hear today is that that is out of balance. That heat coming in is greater than heat going out, and that would make the Earth warmer. Now, carbon dioxide is increasing at 2 parts per million per year, or about 0.5% a year. The theory is humans are adding more carbon dioxide to the air and enhancing the greenhouse effect. The fundamental question is this: how sensitive is the climate system to a doubling of carbon dioxide? A doubling of carbon dioxide is called the climate sensitivity. That is, how much temperature rise will you get with a doubling of carbon dioxide? And again, the greenhouse effect basically works with the sun warming the ground then warms the air, the greenhouse gases absorb some of that heat trying to get to space, and then re-radiate it towards the ground, towards the side, and some back to space. Now here's another question. Are increasing carbon dioxide levels capturing more heat trying to escape to space? Or in other words, is the greenhouse effect getting stronger? That's the fundamental question. Well, fortunately, in the 1980s and 90s, we had a satellite that was measuring the amount of heat escaping to space. The very issue we want to know about. It was the Earth Radiation Budget Experiment satellite, measuring outgoing long-wave radiation, heat, coming from the Earth. The satellite measurements showed more heat has been escaping to space, not less. So the computer models all predicted that the amount of heat would decrease, meaning the greenhouse effect was getting stronger. The measurements showed the opposite, that more heat was escaping to space. This means there has been no increased greenhouse effect as predicted. Other natural forces are changing the climate, not increased carbon dioxide. Now this is the long-wave radiation, or heat, escaping to space since 1974. It showed that, indeed, there was a downward trend in the amount of heat escaping, down to about 1994. And if the atmosphere is sensitive to carbon dioxide increases, this would continue to be the trend. But instead, this is the trend. So more heat has been escaping. And then you have to consider the logarithmic decrease in warming as more carbon dioxide is added to the air. That is, the more carbon dioxide goes into the air, the less warming impact it has. It's logarithmic. That is, you get the biggest changes in the beginning and very little at the end. It's like taking a dry sponge and putting it on a table with some water on it. The sponge is going to soak up that water very rapidly at first, but once the sponge is saturated with water, it won't soak up any more water because it's saturated. That's what happens with carbon dioxide. Carbon dioxide has increased 110 parts per million since 1850. Any further increase will have little warming effect. Basically, it's punched out. Most of the carbon dioxide warming should have been from 1850 to 1925. But even with increasing carbon dioxide levels, there was a 35-year cooling trend from 1877 to 1912. So this indicates the atmosphere is not very sensitive to increases in carbon dioxide, even when it was more potent. Now, the IPC computer mid-range forecast is 7 degrees Fahrenheit by 2100. Where do all these predictions come from? They come from computer models. A computer model is a mathematical representation of the climate system. Oh yeah, I just said that. It can only predict future climate if it fully understands how the climate system works. There are claims that computer models can accurately predict the climate. Now, climate models assume that warmer temperature equals more moisture in the air, and that equals warmer temperature. But is that true?